4.75 from here to here. Now, Vicky moments ago, suspend the nylon seal back here to the opening that we cut earlier. But we're not going to run it directly. Obviously, we'll go through the aileron well. So we're going to go through this bottom forward corner that we did for the drain. And so I took a magic marker and I marked right up over the top of these holes. Now I'm going to try and run, I'll drill a hole here and here, and then eventually I'll get down to the surface of the wing and drill holes along the surface and then bring it to the forward corner of the opening. We'll drill those holes and then come back and give you dimensions. Okay, we're back. I got my drill out, 3/16. You can see there's my marks here and here. It's a straight line from here to it's a straight line from here all the way to the forward corner of that aileron closeout. So now I'm going to put this about right in the middle of the rib. And I'm going to even center the back of the drill on the nylon seal so that as I go through, I'm aiming right at the other point. And you're wondering, why am I bothering to do it this way? It's because I want the smoothest possible rudder movement, and I get that by generating a straight line with as few angular changes as possible. Now at this stage, I can go right to the bottom here, drill it directly beneath this point, and drill through. I'm going to drill these other points, and we'll be back with you to show you the results. Okay, here's our marks again, right there, so the two marks. I'll place the drill bit on the surface, and you notice I'm pointing down. You're thinking, oh, he's going to go into the skin. Flex the drill bit. There's a start. I'm even pointing the drill bit somewhat at where I want to make my corner. The other end is already drilled. Well oversized, mind you, but no big deal. Now this is the only place where I have to make a slight bend. But this being nylon, it's self-lubricating, and it will never wear out that corner. So now we are where we want to be, and I can put a little tension on it, 5-minute epoxy in a few places, put down some glass to hold it, and we're all set. Back with you shortly. Okay, we're back, and we're going to describe to you a process to make you feel comfortable about where you're going to lay this conduit in regards to its ability to move and decrease the friction from the change that has to occur in this line. We have described here where approximately, plus or minus the 1/16 of an inch, where the hinge line is on the other side. So when we describe this arc coming into here, it comes from this point. A pair of dividers there, and you can see where I follow the dotted line. And it starts to come in more profoundly at an angle here. So we have to figure a compromise. The first portion of the arc is through here, described like so. We'll just keep describing that arc. Like so. But by the time the end of the rudder control horn comes inside, it's not coming inside much. So what we're going to do is we're going to run this rudder cable conduit as you see it here. And we're going to run it about 1 inch from the inside edge here. We have to have room for the end of the horn, for the swedge, and for this to be able to move as it changes angle. It's going to swing down as the horn comes inside. If this is badly placed like so, what it'll do is as it gets to the end, it will bend the end of the cable and eventually will break your swedge. So we're going to compromise, and about right where this screw is that I presently have holding the wing against the fixture is about where I'm going to want to be. Now your structures here This tapers out, and this is where you start going carbon to carbon. We have to put this in place and then with super glue and check and see if when the wing comes down that it doesn't grab a hold of this. If it does, we're going to have to grind away some material and make certain there's sufficient room for this to move inside the wing. Now, judging by where this is, I'm going to have, you see this right here? I'm going to have just enough room for this to be able to move, but back here I may not have enough. So we'll try this out and by fitting the top wing skin on, and we'll be back with you with the results. All right, we've got 6 inches of this nylon seal sticking out of the tube. I had Miss Vicky pull on the other end while I pulled taut on this, and we put a mark on either side of the bulkhead onto the nylon seal. We did that all the way down. Then we pulled this out, and then we rotated it and sanded the devil out of it for about 1 inch in length, equidistant on either side of it, not a full inch, but 1 inch wide, about 1/4 inch on either side of the bulkhead. And the scratches I'm making going circumferentially around the piece of nylon seal. Did that at each section, and then as we got down to wing rib 9 here, it goes right against the surface. So with it pulled taut, I put marks down it and I scraped up the area underneath it. I don't want this thing buzzing and transmitting noise into the airframe. Excuse me. So now we've got each one of these ribs, the area on the nylon seal, sanded, roughed up pretty good. And now at a distance, 13 inches out from the opening, is it clearly visible, Vicky? Here. And 3.5 inches forward, we have the nylon seal coming straight out. Now we begin an arc. And the next major point on that arc, we'll describe at 9 inches. At 9 inches, it is 2 inches, 2.25 inches from the trailing edge. And then it pretty much points straight from there at this opening. We're probably going to end our attachment of this nylon seal at about this point, allowing this to move. Zoom in. We'll reiterate some of that from before. At 13 inches, here, you are at 3.5. At 10, you're at 2.5. And at 7, you are 2 inches precisely. And that's about where we're going to end with our attachment. I'm going to sand this area, and we'll be back with you in a moment. It's this first 6 to 8 inches I want to make certain. Really well sanded. I'm going to remove this screw here in a moment. And the rest of it I'm going to lightly sand. So if I need to tack this down, I don't have to try and sand it while this is in place. I'm going to remove that screw for this operation, and we'll be back with you in a moment.
Okay.
All right. Now watch the magic glue. See it mixing through the head. It's already mixed. I'm just going to put some strategically placed material here. In order to be able to go about with this process, now down here, I know you can't see that one, sorry. Let's go about every foot. You don't need much of it. Now we're going to go on down a little ways, and I'm going to put a little tension on this. And every so often you can check the tube and feel if it's getting hot. It hasn't yet. Here's our nemesis, the foam. All right, now I'm packing material right around an opening here. Oh, you're lucky if this doesn't just harden in the tube. This is not 5-minute epoxy. This is minute and a half epoxy. And it lives up to, it doesn't say that on the tube, but in effect, that's what it is. All right, now I pull this tight here. I want this taut up in this end. Doesn't have to be, but I'm shooting for the best. This is going to go off, so I'm going to take it off. It's not hot yet, but I'm going to keep a little tension on it so I get this thing straight. We'll be back with you in a moment. Okay. See how this is loose here? I'm going to push some of that resin inside that tube, inside the hole. And then I'm going to pull this back just a touch. And, oops, that one's already hardening on me. On that end. It goes off like a shot, and when it goes all at once. I'm almost ready to let go here, but not just yet. Boom, 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 boom. It's curing up on me. If I had a chisel, I'd remove the portion. Oh, that's working. On the other end, we're going to apply some glass. This is almost sound enough now where I can let go. There we go. All right. Firm enough now. That's good. That's good. So, we take the weights off, and we get ready to lay up some glass out here to fix this end, and we can put little bits of material in other places, just enough to make sure it's not going to buzz on us at a later date. In flight. Back with you shortly. Back with you again. You notice we have a weight holding things in place, and what we've discovered here is we put the top wing skin on and figured out that if we go any further aft than from the bottom edge of this to the trailing edge, if we go any further aft than 2 1/4, that this just about gets interfered with the closing trailing edges of the wing skin. So I mix up some West, resin underneath here. We're going to do this for about 2 inches in length. I've sanded the devil out of it. And put the resin on. And I'll take this and mix a little bit of flux. Push flux into the side, 1 ply a bid for the length of 2 inches, about a 1/2 inch on either side. We're set to go. The dimension where the glass ends is from this forward edge here to here is 4 1/2 inches. Give you plenty of room for it to flex, and we'll be all set. We're back. Let's see. Let's get you a close-up of this glassing business. My eyes are getting so bad these days, I can't tell if things are in focus anymore. All right. One ply will do us. Push that over top. And, can you see that, Misha?
Yes.
All right, that completes this portion of the program. It's blast in, 5 minute in place so it doesn't buzz. It'll line right up. I'll give you the last dimension here on the front end too. I know it's 2 1/4 in the center. It's about 2 3/8 at the back end. Again, at 4 1/2 inches from the forward portion of the cutout. It'll have quite a bit of latitude to move. We just don't want this so far aft that it gets caught in that groove and not allowed to move. Its ability to move will help prevent a clinch at this end of the sledge to the ferrule and then cause the cable to break. Which, by the way, if it does, you yank it out from this end and you run a new piece of cable in, put a new ferrule on the end, and off you go. But it's not a good sign when they break, because it means that there are things going on here that's going to cause them to break again. We had one Berkut that did that, and with that knowledge in hand, we've never had a problem with it since. Thanks so much. What you're looking at here is a tube, is a hole that's been drilled through here. Started off with a 1/2 inch drill, opened it up to just above a 1/2 inch with a special file. Now Bram here is going to run the tube through, and I'll guide. Okay. A little bit right there. Okay, right there. Push slowly. All right. Now this is very soft tube. The holes that we had drilled earlier here are just about right for. Now so just keep playing it. Oops, stop. Okay. Now I'm going to start straightening the tube, which I can do with my hands here. Okay, ready? Go through. All right. Okay, hold on. Hang on. Here you go. The tube is stiff enough that by the time we get to the end, we're not going to need to attach it to anything. We'll let it float. And we haven't practiced this yet on this particular plane. You're seeing it happening the first time for real. Okay, stop. We're actually further than we need to be. Okay, come on down to this end, Mishka. Bram, you can pull. All right. Now the trick here is going to be to get everything the right shape and guide in. This is already bent the wrong direction. Okay, push a little bit. Okay, hold it. This goes, we have to loop around just a little bit. There you go. It's through. Okay, good. We're inside the tube. Now what we're going to do on the other end here is clean it up so that there's no burrs on the end. And I'm going to move this around and pull this back, and I'm going to scratch this up, put 5 minute epoxy on the inside of the tube, reinsert so we have a complete seal there. And then we'll put some epoxy on a few other places and make certain that it doesn't make noise squeaking around inside. That is the conduit for the strobe 3-wire conductor, shielded conductor, so we don't have noise on the other line, which is the antenna line here. They've been run before inside of the conduits that were in the long easy wing without noise being transmitted, but don't want to take any chances having it inside this tube. Makes the parts changeable, removable, serviceable. This will never be serviceable, this cable, because of the nature of how it's attached up here at this end. So we'll be back with you after we've done our next step. All right. You notice that we've got the tube in place. And I've got this bent so that it was a little more acute angle facing forward. And the marks you see here are where I'm going to sand with 80 grit. And the marks you see here, 80 grit. I'm going to get all those sanded up. I'm going to sand the other end, the inboard end as well. And then very, very quickly I'm going to squish epoxy in here, smear epoxy. Squish epoxy onto these, maybe pull it back and forth so that you get epoxy inside. And then I'll do the same 5-minute operation on this that I did on the rudder cable conduit. I'll get that in place, then I'll stick something on the inboard end of this tube, the inside of the tube, and flare it slightly so I don't damage my cables going in and out of the conduit. Back with you shortly. I should be wearing gloves for this, but oh blast, I forgot to sand. Back with you in a moment. All right, here we are. This time we've sanded it all. And we start the mix again. Hope that nothing else goes wrong. Now I'm going to have to go like crazy here. I'm going to put the goop on the tube and smear the tube. Misha, I'm going to put the goop on this opening here and you smear the goop into the hole. I'm not going to have much time. Okay, around the tube. If it takes me more than a minute, I'm screwed. Okay, here we go, around the tube. You got to find it, Misha. Okay. Now, on this side, you can't follow me on this one, so trust me, she said. That was Freudian, wasn't it? Okay, here we go. I'm going to put some extra of this material on this, and in we go. Okay. That should be about it, guys, right there. Now I'm going to push material around this perimeter. Misha, here, on your finger, Push it around that tube and give me no gaps. Remember, we're trying to seal this so that we don't share that atmosphere with any other. There you go. Oh, you got stuff all over your finger. Here, this whole stuff. Okay? Now I'm going to go to the other end here. You're not going to be able to rush me on this, so I'll be back with you in a minute and show you the results of this near catastrophe. Okay, recording again. Let me make sure we got sound here. And we do. I'm going to give you a zoom in on that. There it is. Plenty of goo. There. And there. And lastly, the other end. That one's really clean. And now I'll show you the inboard. Okay, we're back. I cut this off. It was considerably longer a little while ago. And so I could feed it and pull it back and forth. We'll grind this off and we can take it back quite a ways, and then I'm going to put just a little flare on this using my imagination, and I'll show you what that looks like in a little bit. Okay, this is one way to put a flare on it. Just roll it around inside the tube. It opens up the end. The further out you come, the steeper the angle gets. Stretching that tube out. And once you get out a ways, we've stretched it quite a ways. But the last little bit is what I want to flare here. And I have another tool for that. I'll be back with you in a moment. What we have is a regular old socket with a rather steep edge on it. Take it in little ways. Unfortunately, this end is just a hair large. I'll get a slightly smaller one. We'll check that again. Okay, what we're going to use is the ball peen hammer. You're watching in real time. If I screw it up, it'll be right in front of you. You can see it flaring. Shouldn't need to be held, Misha. I want to roll that corner just a little bit so it doesn't damage the tube or the wire coming out of it. No burrs anywhere on the edge of the tube. So we flared our tube, we're done here. Good morning. Good morning. This little section is on fuel caps. First, the name of the cap is Newton, part number 05-28658. Available in locking, that would make this machined surface here, or I should say forged surface. That'd be drilled and have a locking lug in it. It's light, beautifully designed. I've been using them for years. The ring is the best I've seen in its adaptation specifically for bonding. Drill small holes around the perimeter, grip blast, coat with epoxy, bond in place. And it'd be from the underside, and then apply flux into the holes and a layer of bit. And that can all be done upside down so that it just nests into the upper skin of its own. We'll show you that process as we go. Cap goes in. The nice thing about it is that the only way the cap can be put into the opening is in the unlocked position. And once it is turned, it cannot come out. And then when this is down, unlike the glass air cap, you can put the glass air cap in, lock this, and it'll still come out if it hasn't been turned before closure. Won't happen with this cap. This is the one I recommend. It's the lightest. It's very reasonably priced. It's available at aircraft stores. Buy it. Okay, we're back to describe the installation of the aforementioned cap. We'll give you some dimensions here and show you where it goes. And there's the inboard end of the wing. There is the cap's position. Okay, the edge. Now? Okay. My apologies. I was leaning on my transmitter in my pocket, which has a stupid mute function that gets in the way. Okay, so if you want to fudge it, give it 4.5 inches inboard. That makes what gives some room for where the rib might be. And measure from the back, right at the end of the aileron, or even the aileron trim line. Let's just use the aileron trim line. It is 19.5 inches forward, and again 4.5 inches inboard. That gives me a little fudge. I've got the marks marked a little closer to the tape and a little closer to this edge. You're going to fuel this with the nose down as you do the rest of the airplane. As you can see right now, this is the high point in the tanks when it's straight and level, but that is not really pertinent at this particular point. It's in the nose down position that it will matter. So, one more time. I haven't notched into the hinge yet. 19.5 and 4.5. All right, we were talking earlier, just moments ago, about the placement of the cap, and we have some things to consider. Since you have a 1/4 inch core from the inside skin to the outside skin, we have to make a bevel from this depression that we're going to cut at about a 45 degree to the surface. And then we're going to cover with a ply bid. That ply bid might end up between the spar, this lip on here, and the inside skin. We don't want that. And the same thing could occur on this edge. So it means we should move down another 1/2 an inch and over another 1/2 an inch to just give us an absolute, so let's say, I think we can go 4 3/4. 4 3/4, and we'll say 19 3/4. 4 3/4, 19 3/4. We'll be back to show you the ugly reality here in a moment. We're back. Okay, let's drill this hole. Now, first thing is we're going to show you the hole saw is slightly smaller than the lip in the center. But these hole saws almost always blast. And we'll tighten this up and we'll be back with you in a moment. Try it again. Fully committed. Well, we should be. Doesn't quite fit. Well, we'll start opening that up until this just fits in there nice and snug. And we'll be back to you as we flip things over and start beveling foam on the interior to receive the entire lip. Now we're back. Here's the inside of the tank. This line approximately here defines the edge of the T-tape. This edge defines the forward T-tape on the spar. So you can see this is the cap line. This is the bevel range, and this is the lap that we're going to have of glass in this area and here. So we're just about where we want to be. That's now what we're going to do is we're going to grind away all the way to this edge, to the exterior skin, and then trim the opening to just fit this ring. Back with you then. Okay, here we are. We use the die grinder to grind this. This just drops in with a little bit of room around the edge. It's a nice square end on this, so I was able to go right against the skin and cut. Now I'll go in here diagonally and cut the bevel. Being very careful not to let this bottom corner here touch the exterior skin because it'll cut right through that thin skin. And but the next thing I want to do is if you look, you can see this doesn't quite fit in on the inside, so I'm going to hand sand carefully until this just clicks in. And I'll be back with you for the next step. Back. After some thought here, I want to describe some things to you that you may be able to see the gap between the edge of the cap and here. You can also tell that there's I can go from here to this edge with a very low angle. So what I'm going to do is drill the holes in here, brush on the resin. I'm not going to put glass down here. This is carbon, you say. Yes, it is. But it's also anodized and non-conductive. So the light grid blasting will not remove the anodizing. And then I brush this with resin. This will all have been pre-sanded, of course, all the way around this opening. The entire area, actually, because this is going to be prepared for fuel seal. And so after brushing on the resin and the application of flux, squish this down inside and then do a transition between here and here with Flocro, not pure flux, not pure micro, and then lay tape up onto it from here up onto the edge, capturing it soundly between these layers. We'll go through this step by step as we proceed. Shoot. Okay, we're back. We've sanded in here, and we've sanded out about that far. Now I'm going to drill holes in this, and I'm going to drill number 40 holes in the perimeter, inside, outside, inside, outside, inside, outside. And I'll be back with you to show you that, and I'll have grit blasted and applied resin to it by that time as well. Now, welcome to the headless spokesman. We have, you can see on the back side here, I've taped this lip, this first lip here at the bottom of the ring is approximately 0.2, almost 1/4 of an inch wide. I've taped over that entire thing, which closes off the underside. I've drilled number 40 holes alternately, boom, 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 all the way around. Don't get too close to the edge though. And then on this side, I've taken my masking tape and I've pushed it firmly on the interior surfaces to protect them and squeezed them off to the tape on the underside down here. And now that I've got this stuff squeezed well all the way around the perimeter, I placed my razor blade in at the bottom here in that corner, affecting that. Now I'm going to grit blast these surfaces. And I know that my grit blasting is probably going to lift this tape just a little bit, so I'll end up effectively still getting a bond to that edge. But that edge is only about 0.05 high anyway. We're dependent on this surface and this wall to do our sealing. It will not leak. I've never seen a ring that's bonded into this type ever leak. So I'm going to go ahead and trim this the rest of the way, all the way around. I'll show you the results in a moment. All right, we've just grit blasted, and I did minimum grit blasting. Now what I'm going to do is I'm going to cut this tape away from the lip so it doesn't get caught up in my resin process. Also note the gloves, very important. You can see clearly right here. That edge is not grit blasted. And there we go. Little material right there, get rid of that. Check it all the way around. Now I haven't got, that inside's completely protected. I'm going to leave the tape on both surfaces. There goes the resin on the interior. I didn't want to do that. The tape protects me. The grit blasting we did was just enough to etch the surface. I don't want to go through the anodizing because the anodize is my dielectric, prevents me from the carbon fiber. If you're concerned about it, you can put a light layer of thin glass down or full layer, and there you go. Now I'm going to apply the resin to the interior of this. This is West 105, 205. It's a warm day. We have a fan and a condition going outside. This isn't going to last me very long at all. Now I'm going to mix some of this to flux, and I'm going to squish this in place here. And I'm already centering up, and the holes are already filling with resin. I'm going to mix the flux and be right back.
Okay.
On me. Okay. Ignore the phone, people. There's the flux. They brush the resin on. Flux is thick enough to squish out, and I'm going to find the center here. There it goes. Now I'll check the inside and make certain that, or the other side of the surface, and make sure that it is where I want it to be. It's flush with the exterior at the moment. Now I'm going to pack flux into this outer ring here. I said flux over before, but we're not talking about enough material here to make that big a difference. So okay. You can go right up against that center flange, up onto it a little bit if you wish. It's not going to hurt anything. going to brush, let's check the container, and start to warm up. I'll have just time to put one ply a bit around this, around the entire thing before it gets too hot. And we'll be back in a moment. Okay, we're going to run this tape now around the perimeter. I could have cut one piece of glass with a hole in the center. Let's see how we're doing here. See if we can pull this off. If we can't, I think I'm just going to do it in pieces. So we'll be back with you in a moment after we... stick with me here for a second. One piece. Take the resin. Some of the flux is coming up the wall, which is helping me make the transition of that tape along the base. We're going to do this a different way. We'll be back with you in a moment as we modify that method. Come up here, hon. Okay, we've got a piece of square cloth, fold and fold, and you can look at the width of that cap neck, and you can tell it. Well, the radius of that's about about an inch. So I'm going to come in, cut a quarter of a circumference there, right there. Open, and see, it's just a hair larger than the neck. You can do that by air, or you can do it by however you wish. I'm going to mix a little more resin because my resin's gone off. The west, it's warm today. I'm only going to wet out to about here, and then we'll sand the rest of that off later. And I'll be back with you in a moment. As you're seeing is I'm putting on the second ply right on top of the flux. I'm only going to wet out again, as I mentioned before. I may end up sanding most of this off back as close as I can to this corner, and the same thing over here, but we'll check that against the fit of the T-tape when we reach that stage. With the temperature being in the upper 70s today, Vicki and I are going to go to lunch, and when we get back, this will be easily firm enough for me to trim and handle. But then I'll have to sand the rest of the perimeter area and get ready for the tank seal on the Jeffco. Okay, there we go. That's it for this section. That is your cap installation. Got a little cleanup to do, the tape to remove, and that's it. All right, it's just a little soft. I'm going to leave this tape on here for obvious reasons. I don't want epoxy on this or even the sealant material on this surface. Everything that's going to get sealed is already got epoxy on it. So I'm going to sand around the perimeter of this thing in preparation for the tank sealant. And before this fully cures, I'm going to get tank sealant on this surface area, making certain not to get into the areas where the T-tapes are, either here, outboard at the next rib, or on the leading edge. And I'll define that as we go, and back with you next. Okay, here we are. We're on the other side. Let me give you a quick expose of what's going on here. Nice clean fit. The ring is flush. It might be a hair above in a spot. We could take a Vixen file and file this absolutely flush. We wouldn't be losing more than 10 thousandths on an edge. So we can either let it completely cure, or I can take a razor blade and clean all these surfaces off now. Not much. You can see my original proposed spot, my second proposed spot, but I moved over, and thank God we did. It just clears everything very nicely. Cap's done. And so let's proceed. Okay, real quick visual representation of what you got to have. You notice that that's the Jeffco sitting there. It's not a whole lot of material, but combined, there's 2 parts of the resin, the gray material, and 1 part hardener. That gives you the correct mix. And you can do it visually just across through the clear containers. We're going to mix that together and then apply it to that surface. And you can see I believe you can see the marks right there, that line. That defines the perimeter of the opening. That line there, the big one. That's 3.5 inches from the edge, but might be a little different on yours. You need to just make certain by measuring that you miss the front of the spar, just inboard of the outboard rib, and the lap area along the leading edge. And everything else will turn gray. Back with you in a moment. Can you hear me? Okay. You can see my lines here, I hope. John, can you see them? Yeah. All right. First thing I do is you'll notice that there's sometimes sand. Wipe it someplace else. You'll hear it scrape. Take it right up to the line that you put down to define the edge of your T-tape. And this is much more important than this. We want to push this material into a porosity. So you'll see me going over it and over it and over it and over it. And at some point along this process, I'll take out a heat gun and I'll heat this. And the porosity beneath the laminate, and there always is, don't kid yourself, it'll bubble like crazy, and then I'll continue to push this material down into these holes, and when it cools, it'll suck the material in and help me seal it even further. Obviously, if you've got a gloss on the surface and there's no pinholes, you should have a seal, but I feel much more comfortable knowing that the material is actually filling at porosity, and I can even feel more comfortable about it. In a moment here, I'm going to come back and you can hear the sand in there. Every time I do that, I should wipe it with a paper towel and take that bit of sand out of it. Okay. And we talked earlier about this tape missing the T-tape edge. Looks like we've got it. And I'll get a brush and I'll brush in here as well. Get this stuff all the way up around here. This glass is still active. I did not let this fully cure. It's hard enough to not move around, but it's also hard enough to let me taper the edge when I sanded it. Okay, I think you get the picture. We'll get back to you as we apply this. I'll apply a little bit of heat, maybe you can see the bubbles. All right, there it is. It's pretty well covered, and yeah, it's really glossy there. Let's take it back some, and if it doesn't flow the way you want it to, give it a couple of hours. Come back and put on a second coat, and back. But if you second coat it, be careful about the application of heat. It'll try and bubble up from underneath. Start. Okay. It's been about 40 minutes since I put this on, and remember the temperature was about 75 degrees. And this area here, the material began to cool down, and it really thickened up well. And I must admit, the last bit of the material I put on very heavy. And after a half an hour, it was tacky enough that I could remove the thicker material from here and move it up to the thinner areas. It leaves a mark, but it only leaves a mark for a short period of time, and so I can more evenly distribute the material and get a heavier coat without having to go to a second application distributed overall. It's starting to flow out now, and so that's it. We're not going to do anything more with it, and that one coat will be plenty, more than sufficient. Give it a half an hour, keep checking it until it's really firm, and then squeegee it to redistribute the layer. It'll also help work out any pinholes. So that's it. Let it cure, and then we'll begin our preparation for closure. Okay, we're done with the tank, and we're going to start prepping and sanding for bonding. The last thing we have to do, there may be one other, is make up a spring retract tube that goes in the vertical stabilizer. You take 4.5 inches of your elevator torque tube, square it up on the ends, and I went over to the bandsaw and I put a bunch of made teeth. They don't have to be real sharp teeth, just bandsaw a bunch of slots, about 1/8 of an inch deep. I stuck it in the lathe and used the tailstock to push against a piece of plywood that I held and made cuts like this in the sheet. And you can go in half the thickness of the plywood. I didn't go quite that deep on this one, but half the thickness is fine. And of course, it's going to fit precisely into the tube so it doesn't jiggle around. You drill, I'll show you the drilling of this for the hinge pin that you'll use as the hook on the inside that your spring hooks onto. Once we've done all that, I'll put this in place and use super thin, super hot super glue and drip it on the inside, which will wick into the wood, seal the wood, and bond it in place. And I'll grind the outside to match the tube final. I'll grit blast the tube, stick it in place with 5-minute epoxy, and then brush it with resin and put 1-ply bit over top of it with micro on both sides where it's to be positioned. And you'll notice on the winglet, I've drawn a black mark at the bottom of the hinge line and up about 4.5 to 5 inches, another line, which I can see through from this side. We'll give you a view of this side in a moment. For those of you who are wondering, what is that? Well, that's 2 layers of duct tape on my fingers so that I can push 40 grit, 36 grit sandpaper for sanding the bond lines where the ribs hit these surfaces. And I've already sanded all the T-tapes and all the areas on the wing where bonding is required. And I'll show you that on the underside of this skin in a few minutes. All right, this is the inside skin. And having been able to see through, this line here defines my hinge line. You notice the color change? When I told these guys, my laminators, to run this skin all the way to here to reinforce it, they only ran it to the hinge line. I'm going to have to make up for this later on because I want this skin and this skin to be the same thickness when I put the hinges in place. This line here, you can see at this point it's 4.75 inches from the bottom of the rudder along the hinge line. At the back end it's 2.25 inches long. And this defines where I'm going to put my tube. I've also measured from here to the 2 vertical members on the opposing skin to determine exactly where my closeout members are. Otherwise, I won't know where to put the wire that goes here with a hook on it, and I won't know where the end of this is supposed to go. So the way it's going to look is like this. This is going to go right there with this on center line. And then I'll cut a notch in the VS1, vertical stabilizer, close out, and then I'll put a teeny notch where the wire comes through here with a hook on it. And the hook should face the center of this tube so that when I go to hook the spring up on the inside, bring the spring across here and hook it to this, it'll be right in line. And we'll be back with you in a moment for the next step. All right, this is a bit of a challenge. We have our little plywood pieces I showed you before, and the hinge. We've got a heavier hinge than I've used in the past. Berkut's always had a bit of a problem with not being able to feel the rudder. The rudder's very sensitive, and the more feedback you can get from a spring, the better off you're going to be. So, gather up all the elements of this process. The spring, we'll give you the part number on this spring. It's a Century spring purchased from Orchard Supply. Needle nose, not needle nose, but you can use the needle nose pliers if you want the needle nose vice grips. I get a hold of the end here, clamp it good, and we're going to bend this 90 degrees. Right about there, first end. And I'm going to go to here. Okay, we're going to shut off for a second for the children. All right, the elephants have gone back upstairs. Now we're going to make another bend here as close as I can to the other surface. Again, 90 degrees. I want those two edges parallel. And this is piano wire. I believe this is like 80 thousandths piano wire. It's the same as a regular hinge pin, which I would encourage you to use since hinge pin is also plated. It's cat erudite plated. Now I'm going to drill a hole in this, and I can come close to centering, but I can't center precisely. If I center precisely, it gives me a problem on the inside of the tube. And I'll illustrate that here. The spring will go inside the tube, then it's going to have to go over a mocked up hook here. And to do so, to go over this, the spring has to be up pretty high. And from this point to this point, as it's going over the top, it would be, if I placed this in the middle of the tube, I'd never get the spring over this end. And if I did get it over the end, I'd certainly never get it off. And this needs to be 0.3 from here to here, 0.32, 0.35, and you can see why. Clunk. Goes over top. Now I couldn't install this the way it is. I have to install it with this unbent through the wood, through both holes, and then I do this final bend. And I'll give you the dimensions here of this. This is a fairly good mock-up. The distance on this edge need only be 1/4 inch long since it's going to go through the plywood. This is probably just a little bit long, but that's okay. So it's 0.3 maybe. And this leg here is 1.5 inches from the inside edge there to the inside edge of the band. And the distance measured this way, not this way, is 0.35. And you saw how I did the bending. And now I'll cut this off a little long. I'll drill the holes in this. I'll show you those positions and show you the markings in a moment. All right, you can see where I'm right near the edge, about 1/8 of an inch away from the edge. And the width of this, where these two holes are going to be drilled, is dependent on how you've bent this. So I'm going to drill this one, number 40, and I'm going to come over here and, actually I'll drill the center one first. It's not exactly center, but I'll drill that one first, and then drop this in, see where it hits here. Drill that one, pull it through from the opposite direction, and then we'll do the final bend. Back with you. Okay, we've drilled the holes, as you can see. There it is. And we used a number 40 drill bit. Mentioned before, we drilled this one first, and now I gave you the dimension for this earlier. I'll give it to you again. The dimension from the wood surface is 1.1 inches from here to the bend. I'm going to move to the center here, Vicki, so you guys can see it. 1.1. And now I have to make a decision where I'm going to do my bend. That's about it right there, 1.1. Now I'm going to move, Vicki, so that I can make a bend. So follow me, please. Okay, I want this bend to bend up towards this pin. So I've got this point here at 1.1, which is wrong. I should have that point at 1.1. And I should have the pliers over. And the reason for that is this is narrower here than this is, and it'll be easier for me to bend over the top of itself. Okay, now then, here we go. Bending. Well, that didn't work. Cut. Well, if that happens to you, it means that we bent a little bit too tight, and you may want something a little thicker to reflect more of what you see right here. little larger radius. And being on the edge of breaking is pretty good because it work hardens the material and prevents it from unbending when you need it to remain in this bent condition. So I'm probably going to use this one anyway. And the reason for that is that, I'll be right with you, is that I'm not going to use that as a hook. But where I place my bend has an awful lot to do with how close I get to this edge when I come over top. So I've still got the latitude to bend this again and reuse it. So we'll be back with you in a moment. Okay, we'll do it again. Let's take a look. Now come up with this a little bit. This will increase the radius. Just a little bit more. Okay. Now straighten this out. And probably not sufficiently bent enough. So I'll open this up a little bit and we'll hang on, Devin. Broke again. Back with you soon. Yeah. Okay. You can see that this doesn't go all the way to the wood. I'm going to bend it again. Do it again, but next time I'll put a radius on the edge of the pliers. Here, I'll find some cheap bare pliers to put a radius on so it doesn't bend and break. But the whole idea is that I can't bend it again because the next time this would hit before I got past the bend point, so that's as close as I can go. And that is the whole trick right there. That's a nice hook. Unfortunately, it's cracked. We'll do it again. Okay, we've ground off the hook on the test piece that we were showing you. And every metal manufacturing process, this is piano wire, has some folding and rolling work in it, so it gives it a grain. And I hypothesized that I just happened to have it positioned in the direction that it didn't want to bend the least. So what you see here is I've got a radius on this pair of pliers, and I'm going to place it like so. And we'll be back with you in a moment. Here we go. Vicky's going to try and stick with me as I bend this as the strength requirements go. I'm going to bend directly towards this pin, and I hope I have enough leverage to do so. Now I'm going to have to get the vice grips to be able to do the last bit of this because it's too small for me to grab a hold of this. So now we're back to the square-edged pliers. And bend. Almost. Okay. That's very close. I'm going to probably go put this on a vise and try and bend it just a little bit more. Let's try it one more time with the shorter jaw. There it goes. Now let's see if the spring will go over top of it. It does very nicely. As we look at it this direction, bring it up. You have to take into consideration two things. Is the imaginary upper edge of the tube coming across here, and will this be that's where the tube would be right there. Will this go up and not hit the bottom of the tube before it runs into this? If it looks like it's going to, then what I would encourage you to do, stay there, Vicky, is this. We'll put this inside, and then we run the spring inside, Let me try and get this to go over top. And you notice it did, but with a little difficulty. So the arm is a little on the long side. So we'll make a mod to the length of this so that it can drop over the piece. And we'll back with you in a moment. Okay, I ran some super thin, super hot super glue in there, putting that pin as perpendicular to the center line as possible. And this goes in. I put the pin in the vertical, and we try it. Hook, and then we try and remove it. Okay, in, out, in. Okay, and make certain you can install it, make certain that you can remove it. And it does both. Okay, after we reach this stage, okay, I'm going to grit blast the inside of this tube, and sand it, and I'll super glue this on here. And when I epoxy it in place, you make certain that the hook is facing up. So you can slide this thing in and it drops onto the pin while you're hooking the hinge together. Now this is going to get shortened, and we'll bend a new arm on it to custom apply the tension on the rudder. All right, here we are. Super glued in place. Ground off, flush to match. Radius on the back edge corner. Super glue dripped in this face, and we're talking about the super thin, super hot stuff. Now this is the up edge here. Bingo, that goes on. Now let's see if it can come off. With a little twist, it does. Okay, nice and tight. And so now I'm going to place it here, and I'm going to make certain that the long leg here is up. I'm going to grit blast this, 5-minute epoxy it in place, brush the West resin onto the tube and the area around it, a little dry micro on either side, 1-ply bit over it, and we're finished with this operation. Okay, here we go. We'll show you just how fast this epoxy really is. This stuff is incredibly strong and ultra, ultra fast. Now, we talked before about what's vertical, and there's vertical. So, Miss Vicky's going to move here to the side. That's where it's going to go. "90 degrees to the edge. I can see the wire is paralleling the skin. I have a nice point of attachment. As part of my head, I'm going to make certain that I'm on center line, which I am. And I'm going to move this way just a touch to make certain that when my bulkhead goes over top of this, that this tube sticks slightly beyond the bulkhead. I can always grind it back. If it's short, well, I'll be a little irritated. Does it look like it's on center, guys? All right. I'll check the epoxy here. Hasn't gone off yet. Okay, you checking your watches, folks? Well, it's not important that you watch just how long it takes for the epoxy to go off. It's like watching a pot boil. And I'm not putting enough pressure on here, obviously, to change the shape of the winglet. And when this stuff goes, it goes all at once. Not yet. Watching a pot boil, watching grass grow. The small amount of epoxy you see me leaving here is not a big deal. There it goes. Bango. So, we'll be back with you in a moment. I'm not going to bother to remove that little bit of the little bit of 5 minutes on there. I'm going to brush just enough resin to do this job on here. Maybe I'm going to seal the wood from the back side. It's been soaked with super glue, but after the grinding I did, I don't know if it's still clear. I mixed more micro than I needed, so I'm probably going to have to go back and do another shot. But one shot should have done this job just fine. Now we've done a wing before for a group of Estonians. It wasn't done this way. This is an improvement on a process. This is not one of those ultra-critical conditions where you've got to make certain you don't have micro anywhere. You can put it anywhere you want. Not going to hurt a thing. I'm not going to bother to glass the end of the plywood either. This is way overbuilt. But you can't go less than one ply, and I can't use a filler lighter than micro. Okay, now we're going to cut the cloth real quick. About 2.5 inches there. That's not wide enough. Let's go a little wider. We can always cut it down. You want about 1/2 inch onto the surfaces. That's big enough. Let's cut it down now. In length. Doesn't have to go the entire length. There we go. Now we wet this out, and we're done. I may have enough resin here. Heat gun would be all right, but it's I'm going to be done before the heat gun gets here, so no big deal. Go ahead and wet this out, and we'll be back with you in a bit. Okay, we're back. This is wet, and now we've got to have a hook. We're gonna basically have a bend, and then the hook comes out here and sticks out to about just short of the hinge line. So let's see, what do we start off with first? Shall we start off with the boogaboo bend? I think we'll do that first. We won't do any real severe bend. That wasn't the wire breaking. And I'll push our luck again. No sweat, no break. I may shorten this up just a touch, but now we decide, okay, where are we gonna go to? You know, the bulkhead ends right about there by the way we measured it before, so we can be out just far enough. So we'll say that this will go right to the hinge line. And I'll start my bend about right there. We want this thing in the vertical. If that's going to be vertical, then everything here is going to be bent in plane. So I'll start right here. If you can follow me, Vicki. There's no magic to this bend. We'll just get this bent in plane. And I'm going to bend it on the back so I give myself a little bit of latitude. I go to the opposite side here. Give it about a 1/2 inch per leg. And you do want to bend it in plane. Sorry about that, Vicki. That's a 90-degree bend. 1/2 inch. And we bend again. Oops. Oh. Again in plane about 90 degrees. Okay. Now I'm out of plane. And if you know what I mean by out of plane, this is what I mean here. We want it all flat. So I'll go another 1/2 inch. Bend. Another 1/2 inch. Oops, out of plane. And for those of you who actually know what Pokemon is, or Pikachu, this looks like a Pikachu tail. And my sympathies to all of you who know what I'm talking about. All right. And my camera person, my apologies for having to chase me around. All right, one more. Okay, there it is. A zig and a zag, a wig and a wag. This is going to go like so. And that places this, and I can even bend this a hair here, so that this ends up approximately in the middle of this tube. And we have some latitudes there. It doesn't really matter if your rudder sounds like a screen door opening and closing when you activate the rudder. But we would like to get as much movement before the spring begins to hit the side of the tube. Not that big of a deal. Okay, I'm going to cut this off here at the end, and I'm going to grit blast it. You can sand it; it'll be captured well within the flocks. This is going to be flocks in here, not micro. And we'll just tack it with a couple of drops of 5-minute epoxy. Let that kick. Brush it with resin. Flocks over top of it. Nice smooth transitions. 1 ply a bid without a cure, and we're done with this particular setup. Okay, people, there it is. Now what I'm going to do here is I'm trying not to touch the portion that has been grit blasted. Sorry. So I'm going to do just a little bit right there. And I'm going to do just a little bit right here at the end. Oh, sorry. Right there, just enough to keep it from moving while it cures. Yeah, we'll be back with you in a moment. Shoot. Okay, this whole thing, by the way, is 4 3/4 of an inch in length. And the placement of this foam may vary a little bit, so use your hinge line as your primary point of reference. 4 3/4, 4 1/2, even 4 inches is plenty in here. I've got 3 1/4 inches of zigzag area here, and there's no way this will ever pull through when you look at the total surface area. Thank you, Misha. Misha here, the Mad Russian, has supplied me with some resin, and I'm going to brush under, over, around, and through. Devin, I'm recording. Okay. What we want to do is we want to keep the weight behind the hinge line down to a minimum. And here we really don't have much of a choice. I think this is probably the lightest possible way that I could have supported the attachment. So we'll get this in place. And I think you get the picture here, but I'm going to show you the whole thing just in case. micro here probably would have worked, but I hate to open the rudder just to prove that's the case. Nice and smooth. Okay, now my cloth. Does it look familiar? That's the piece that I rejected earlier. I'm going to wipe this out, and we're done. We'll be back to show. Oops, I'm pushing on the mute again, that useless button on the transmitter. Completely useless. We'll be back to do the final fitting of this up against the rib here and the rib here of the longitudinal members. And we've already done the sanding of all the T-tapes on the lower wing skin. Now the next thing we'll do is we'll start sanding where the T-tapes strike the upper wing skin. That, as they say. Good morning. We've got hardness here, and I've sanded away the cut use. And now we're going to show you this can go in. If you favor the top and give it a little rotation, it clicks in and grabs. Now we're going to preset the length of the coils here. You can see how much this sticks out. So we know that we want to come back about that far, maybe a little further. So we have just a little bit of tension on this thing when it's set. Go back one more. Now give it a turn, pull it out, and show you the trick here. And Ms. Vicky there will tell me if I'm going out of frame at all. Okay, now we open this up. And then we go in. This is the trick. Cutting it off. The best dikes you've got will be just good enough. Bingo. Okay. You can see I'm short on the loop. Well, there's a number of things you can do to change that. You can see I bent that like so. I keep going. And I bend it further. And there we have it. Just like the factory. Almost. Now let's see where we end up. There we go. Now this is going to pivot from out here, and it's going to go this direction. This being favored slightly that direction actually helps. You notice I've got some clearance here on the wall, and I'm just barely touching the wall on this side. So as it pivots, it will move more toward the center of the tube and give you less noise during operation. So this, by the way, you can see that? I've got about 2/10 of an inch short right there. It worked out very nicely. This is the easiest installation I have ever done, and you've seen me evolve it and develop it right in front of you. This is not something that I've rehearsed or practiced, and this is the heaviest spring I've ever used, which I suspect will give you much more feedback at the foot. We thought we'd better give you a piece of info here before we go any further. This is a Century spring purchased from Orchard Supply. It is Charlie, or C, 231, and I'll repeat that, C231. It's 9/16 diameter by 6 inches in length by .070, that's wire diameter. And we've cut off, inch and a quarter, inch and a half of it. And but you'll custom trim and cut yours to fit. Thanks so much. Good morning. We're back. We've done the trimming and the fitting, and this is what it looks like. You're going to be just over an inch deep here. You slide it in place, make a mark above it and below it, open it up, and then iteratively fit it. This ended up a lot deeper than I thought it was. Make sure it goes completely closed without any kind of force on it. You can mud this up to shape when you close it. Secondly, you notice that up here, I'm showing a rib. I thought very seriously, because of the amount of bond potential area I have on the trailing edge, not to put these in. When you put any object into torsion, what is trying to happen is eventually you're going to end up with an hourglass. It's going to try and squeeze in the center and collapse. So to make sure this is as torsionally rigid as possible without adding too much weight, I'm going to add 2 small ribs into this part. But because of the low loads that it's going to see and the fact that it's only going to be in compression, and light compression at that, I'm only going to bond them in place with 5-minute epoxy on the edges of the material. I'll put the 5-minute on, rub it into place, build it up just a touch, maybe wipe a small amount on here, stick it in place, and then hopefully go up and get the other one at the same time and let them cure. Then we'll trim them down. I will be providing you with templates on this in spite of the fact that it's, this is scrap. This was actually an afterthought. I might have 10 minutes worth of trimming and fitting work in this at best. But we'll provide you with templates for these, as well as the templates for the 2 small compression ribs inside the aileron. I'll be back with you as we get ready to bond. Okay. Make sure that as you're mixing this stuff that you've got your chisel nearby, so that as the stuff that exceeds the area. Okay. You can do 1 rib at a time if you wish. I've wetted the surfaces pretty good. If this is any other kind of foam, we wouldn't be able to get away with this. But this foam is so tough that the bond to the foam cells alone is sufficient to give me the strength that I want here. I'm not going to go back to the trailing edge because I know that it's not going to end up being left behind. It's going to disappear in the trim process. I'm not going to do both at the same time for this. This is about to go off. Well, maybe not. All right. Okay. This is a test of the central nervous system. See if I make it. And did I have enough material to do the job? We'll see here in a moment. I think so. Call this tape Dave. Pushing the envelope. And if you've got your chisel standing by as this stuff cures, you can wipe it clean. It's staying right where it is. These parts are so light. They weigh quite a bit less than an ounce. And by the time I'm done trimming them, they'll be less than that. All right. And I'll be back with you in a moment. Moments later, take it straight in, and we make a cut like so, and remove the excess. If it's not doing anything, you don't want to carry it around in flight. It's only adding to the weight aft of the hinge line. You've seen the actual cure time on the last part, so you know how little time there was between the mix and this bit of video that I'm doing right now. So have your chisel standing by. You get the picture? We'll see you in the next section. Our next step is to slide this upper skin into place here and trim this final with as small gap as possible. Because we're not going to T-tape it, and I don't want to wait for it to do a micro cure on here to fill up any gaps. So we want the gap as small as we can make it. Which brings to light the fact that I shouldn't have put that rib in until this one was fitted. Just like we did, the mistake I made here. Don't make that mistake. It makes it so much easier to just be able to look from the top, see the fit, and then make the trim and get it really nice. It's not going to be that much more difficult for me to do, but it is certainly beneficial to do it in that fashion. So the next thing I'll do is trim this to fit, and be back with you. We left out, when you're getting close to the end of video of the process, preparation for assembly, you stop and you think, and you think, and you think. And in this particular case, I'm glad I did, because we did these two little closeout ribs, those little torsion ribs, and I forgot about the closeout rib up at the top. Of course, I'm tempted to really push the situation along and go as fast as I can, so I can get this thing closed today, but you can't compromise strength. You notice I have a little gauge here I made. It's 85 degrees. And because we're swept here at an angle, it exacerbates any condition that you might have that if the ribs aren't perpendicular to the travel, you can have trouble with as the rudder or aileron or any other structure moves, that it can encumber movement and the two surfaces can hit. So what we do is we're going to set this rib, this line is transferred from the opposing side where your part line is. We're going to put this rib about 0.63, which happens to be the thickness of this gauge, above the part line. And then I'm going to set the rib at 85 degrees, tilted like so that the rudder underneath it, when it moves away from and opens the gap. And it improves, it gets a tighter and tighter gap as it comes closed. You can actually, if you go steep enough, and I've seen this done on the Long Easies by Andy Green, he went steep enough on the surface that it actually closed against the two bevels and made a real nice tight seal between the surfaces. Real positive closure. But 85 degrees here should be plenty safe. I've also sanded the upper face so that after I'm done 5-minute epoxying before I close, I'll put a bead of dry micro in the corners, which would be more than sufficient since the tip of this wing sees little or no load. And make certain that you drill into this cavity so that this cavity can breathe, because it's going to get capped off by the foam and glass on the upper surface here. It needs to be able to breathe, as does the rudder. It needs to be able to breathe as well. So there'll be little drilled ports through here so it can breathe, with an exit at the bottom. This will need to breathe too. This is already open up through here and open there. So we're going to bond this in with 5-minute. We're back in a moment. All right, we're back. We've cut the piece. We slide it in. Get it positioned. Drop in this case, 0.63 piece. Squeeze it in place. Make certain that you're flush up here in the front. Let cure. When that's done, we'll have a nice clean 0.63 gap between the two ribs. And then we'll immediately clean off the excess 5-minute. Put a little bead of west in here and in here. This is going to get glassed over top of later with a 3-ply bid C-channel, but you'll see that a little later. Okay, we've done a number of things that would, as I said, think before we close. We'll run a quick scuff in here. Okay, run a quick scuff in here. And a thixotropic form of superglue. And this is superglue gel. Give yourself some slack from the inboard end. Find the upper edge. There's the kicker. And we're going to put this on. It really holds its shape. Probably not a bad idea to have a glove on. Now, I probably should have done this first, but kick the underside. Well, put wet on there, and rub it in place. Make sure that you get it on the underside, because as soon as you get it up there, we're going to pull this taut, and we hope to heaven that the super glue is facing up. Because as soon as it goes against that zip kick surface, it'll kick. And it'll also glue your fingers together. There it is. It's nice and tight. The nice thing about the super glue is that it bonds to the vinyl, and it will not let go. Will not let go. So this isn't going to buzz or hum up against this underside surface. Do that down its entire length. You're done. Good morning. Here's our winglet. We're going to be working on that in just a little bit, trimming that down and showing you how to make the cut so that when the upper skin's bonded in place, it doesn't fill that 60 thousandths groove, 63 thousandths groove with epoxy. Some assurance that you can remove it later. And then we've got, all right, we'll stick it back here. We have the false spar area. Presently what I'm doing is I'm sanding all this material in preparation for removing that portion of the aileron skin that has no core in it, and it just prevents me from actually seeing up from here, so that when the top goes down I can tell if I've got my bond line closed the way I'd like it to. You want the ability to inspect as much of the squeeze out as possible to give you indications of what's happening elsewhere in regards to the actual integrity of your bond. This is a blind process, and there are certain things you can do to make you feel good about making certain that all these bond lines are complete. So we're going to sand all this. We're going to sand the backside of the whole shoe web down the backside so that when it is closed, there's very little work to do in there. We'll just have that bead of material to remove, and we'll be able to do that from here because we'll be able to see it. We could actually do the layup subsequent to the closure once it's cured enough and it's been wiped enough. Well, it's green. We could still do an aluminum 3-ply bias layup in here on aluminum foil. We'll keep you apprised as we go. We've gone from sanding the the aileron false spar area, which I have yet to do there in the middle of your screen, inboard. And we've gone to the absolute inboard end of the wing and the hard point. We're going to go down about 1.5 inches, 2 inches below the hard point. We're going to sand this entire area from here up, the underside of the shear web, this entire area. Because once we've closed the wing, and by the way, I've pre-sanded this portion of the skin here, as well as all the other areas in this, the interface areas. So when I bond down and I have this wet material underneath, and here, what I want to do, I bend this out of the way, I'll tape it down, and I'll lay up 3 layers of unidirectional carbon spar cap tape from here to about 12 inches back. And then the next one will be a little bit shorter here, and then this will be 11 inches, and then a little bit shorter here to the bottom of the plate, and then this will be 10 inches, so 12, 11, 10, short, short, short. And then we're going to put 1-ply of bid over top of that area, just from here to there, covering the carbon fiber. Then we'll take a 3-inch by 3-inch, 1/4 inch thick 2024 T3 or 7075 T6, radiused heavily in this corner, and with flocks, squish it in the corner, clamp, and allow to partially cure. Put flocks around the perimeter. Of course, you'll remove the clamp by that time, and then you'll put 1-ply of bid over top of that, and you'll have 2 layers of 1/4 inch material here. Allow to cure. That will finish up the structure here. The hard point there is already completely finished regarding structure. There are some things here that I haven't covered that I'll talk about now. These are options. I could build a box using flat stock, rib stock scrap that goes over these hard points and closes just beyond the depression, so that if you guys leave your covers off during flights, that if you have any uranium, no water would enter these things. And if they entered, It's not that they would prevent it from entering, but if water entered, it would isolate the water into this area as if this were a solid foam core wing. This is a point where water can enter, obviously, and if you have covers in your depressions, that's obviously not a problem. But if you're in the process of putting wings on and off, doing testing and other things, then having the covers on is impractical. It's not an absolute necessity, but you can build boxes. I'm going to cover one little detail here that we talked about before. The trailing edge here, my laminator's moved the foam back about 3/4 of an inch or so. And its ramifications were not limited to just this trailing edge section. It also reflected on this here. This should come down, and it should look like, I'll give you a close-up. You'll see that the taper in the foam goes carbon to carbon to here, and then it tapers up, and it's sitting fully on top of the foam and carbon here. And then the further inboard I go, you'll notice, I'm the only one working the camera, sorry, that this it gets wider. Now we go further in. Now it's about 1/4 inch of flat, and then it dives down here. The perspective is such that you have a hard time seeing that. Now I'll show you the inboard end where it is most pronounced and where you have to do something to make certain your aileron does not strike it. And there's a dot right there. That is the cutout line to the other end, to the aileron. I got about a 1/2 inch of flat, and then it comes down, comes very close to the leading edge of the aileron. Well, the hinge point's back here, and as the aileron begins to move, the leading edge comes up and forward, but I don't want it to hit here. What am I going to do? I'm going to hedge my bets. I want to make certain it doesn't strike, so I'm going to do something with this little tool here, and I'll show you that here. I'll take the front of this, which is round, and buzz off just a little bit of that from here to the point where I don't think it's going to have an effect, which is about 2 feet from there to the right. I'll be back and show you the results here in a moment. Okay, now there's that little white dot again. And there's where I've removed the foam with that radius section here. And we take it all the way down to this rib. That's where my transition becomes most profound. I think this is where the inboard foam section abuts the outboard foam section, and that's why it began to swing from here aft. I'll take a little bit of sandpaper and soften this edge. Let me show you that. So, pardon me, body. I'll fold this over. I'll go across it somewhat diagonally. Now, if you're saying to yourself, oh, but you've removed carbon fiber. Well, yes, but the strength in this area is the 3-ply C section that comes in here. It's not this 1-ply of bid carbon and 1-ply uni that's on the inside. It's really rather superfluous. It's we're just making certain that the aileron doesn't hit this skin. This is just a transition area. It's just a closeout. So I don't know if you can see that. Next to it, it's rather square right here, and right there it makes a nice smooth transition. So we'll endeavor to sand to that transition, and then we're not going to worry about it until after we've covered it with 3 plies of glass. Then it's nothing to worry about at all. We talked earlier about making this cut, and I can take this blade and go through here for the most part to about there before I run into this, and so when I get into there, I'll come inboard a little bit, make my cut to here. This is about 1/4 inch behind this cut line. Is it visible, Vicki?
No.
All right, we moved the camera. Now there's the hole I drilled many moons ago, right there, and the cut line that I'm going to use now just to be safe, is a good 5/16 of an inch after that. I'm going to cut through here, cut down there, cut the other end. Back with you in a moment. All right, we've made the cut. Now you can see obviously that I can be down here looking up in there, and I can get up in there and remove the goop that's going to squeeze out when I bond. And now if you listen, that's the part line. And there's the back edge. It's almost got 3/8 of an inch here. Right there. And obviously on this end, you can see I've got a nice gap between, this rib is right on the center line of my fixture. And we don't have to worry about final trim on this, or the inboard end until we're actually getting ready to put the aileron in. But right now, just general access is the intent. All right, we're going to do a little pre-fitting here in preparation for bonding. Putting the clecos in the leading edge at the moment. One of the more critical pre-fit areas is here. One of the most stressed areas in the wing. And what we're going to do might offend you just a bit, but it has some very sound reasoning behind it. We're going to take a number 40 drill bit, and the reason that we did the fitting here is to make certain it's exactly where it's supposed to be. We're going to drill into this compression member here. We know how far our opening is here underneath. You can feel that. It ends about right here. So just forward of that, I'll drill half this angle, 45 degrees, into this corner with a number 40 drill bit, and then uncleco, slide back and open these holes up to the diameter of a drywall screw, because I don't want the drywall screw itself to be threading into any of this external structure. I want it to thread only into the glass behind it, so that when I put this in place and I can tighten these screws up, I know I am squeezing that epoxy in this corner without a doubt, without a shadow of doubt in my mind. I can weight the heck out of the spar cap. That's a piece of cake. I can see this rib, make certain that it's squeezed close. I can put a little weight on it, make certain that it's spreading, which means that I can tell if this area is doing its job. I can put a non-slip something here and put weight on it and make certain this is down. I've got a lot of other little tricks I'm going to have to play regarding making certain this is being squeezed against the surface. And I'll do that by drilling through the middle of the rib with a number 40 drill bit without the top skin on, finding the centers of the ribs. And then coming from the back, then drilling that, then putting the skin back on, drilling through this skin with a number 40 drill bit, 2 or 3 strategic places per rib. And then when then I'll open the holes up on the skin again, so I'm not pulling or threading into the skin itself. And then when I put the skin on, especially in the vertical stabilizer, I'll be using screws to pull onto the ribs on the winglet area. We'll be back. Here we go. Back in a moment. All right, the aforementioned drill bit, which by the way is a number 21, which is just slightly, just slightly larger in diameter than the threads. 3/16 would be too big. Now I'm drilling into space here. We're going to do a trial fit here in a moment. Drill all these out. Let's see if the forward one was unnecessary. No, it worked. It did something. And make sure that you don't drill into your... Now, wouldn't you know it, I came very, very, very close to the electrical connection going into the antenna, the RG58AU. Make certain you check that first. I may have damaged this, and we'll know in a moment. I'm not going to put a screw into the second hole until I've determined that I haven't damaged the RG58AU. Now you can see it drops right into the hole without pulling on the exterior skin. It's exactly the right diameter. Nice bite, really firm. You can feel by holding on to the wing that it pulls very tightly into the structure. Now we're going into 15 plies of glass on this backside, so we'll develop very nice threads into it. There's a distinct sound to solid contact, and we've tried them out. We don't have real long screws here, not necessary, about an inch, and we checked continuity on the RG58. We got lucky. Don't make that mistake. It's very foolish on my part. There's nothing else critical in there that you have to be concerned about. It is the only thing that you've got to be concerned about. Okay, and now we're going to take other steps here in preparation for running screws into ribs, etc., etc. This is not something that I relish doing, but I'm going to have to do so to be certain that I get really good bonding. And I may not, at this first viewing, have this down exactly the way I want. So I encourage you, as I have in the rest of the tapes, to view the whole tape before you proceed, or review a section before you proceed with it. I'm going to find the middle of this rib. I'm going to go through the micro. Then I'm going to go through the foam with the intention of going to the center of the foam and then to the exterior skin. Ooh, I don't like doing that. No. Now, with this particular setup, I have the ability to take straight edges, small C-sections or square stock, and find these holes after drilling back through this skin. Now, these are really easy to fill. It's not like filling the edge of a piece of skin with a little bit of flux and hoping it stays in the hole. It's when I fill this hole, I can inject with a syringe with a relatively large tip with a mixture of West Systems resin and micro, moderate mix, and push it from one side of the skin to the other, and make certain that there is nothing in that hole that is well backed. So it's less offensive than in other areas. So I'll drill a hole here. I'll drill one up at the top, maybe in the middle of this rib. I'll do the same thing up here at the top, the bottom of this rib, and then we'll go looking for the appropriate straight edge sections to use to pull up against the surface. We'll be back with you in a moment. Okay, here's a rib. Now don't drill your foil. Now we just drill another hole here. Do endeavor to stay in the middle of the rib. Again, don't hit the foil. Out the other side. The Clicos will hold it here. Squeeze it right there. The extra holes aren't going to hurt. parallel to the rib so that when you run the screw through, it doesn't end up trying to go through the skin and put a buckling load on the skin. I've got 2 here, 3 there. We've got one here at the bottom, one up, we'll put one up at the top, and we'll be back to you in a moment. You can see me? Okay, what we're going to do is now we're going to drill from the back side with the skin in place, the appropriate screws in place, cleat-cut edges. In other words, it has to be as much in contact as possible. Now, right about in here is where I'm going to drill through. So if you'll focus right there, Vicki, put your bottom of my finger. Okay, you'll see me come through. Now, of course, where I am on the opposing side, I've got my drill is too long to actually get between the jig fixture and the skin. So I'm not going to be able to do that one. And I'm going to go up to, let's see, right about here, Vicki. And we'll show you that one. First thing you do is you stick the drill through, let it guide on itself. Don't push. There's another one. And I'm going to go into this area here where the rib is. We'll be back with you in a moment. Same problem. The whole drill bit and drill unit is too long. I have to get a shorter drill. Back up. I'm pushing on the useless mute button. It has no purpose. Now we'll go back to the one that Okay, now we're going to take these out to number 20 and then run screws through. Now we're into a different area. We're low on tape. What we're pulling into here is foam. It's foam with fair integrity, but we have to be careful. We have to use our feel to make certain that we are not over-tightening the screw. In some areas where we're thin enough, we can use really long drywall screws, go through the opposite side and pick up the skin where it's a number 40 drill bit has gone through the skin. Like up here at the top, especially down here at the bottom, we can do that. Just be cautious, use your feel. Okay, right up here we have the fixture getting in the way of the trailing edge. So I'm going to run a drywall screw through here, through one of the ribs, so I don't compress anything. I'm making certain that the rib is sitting on the surface. And into the drywall fixture, or with the drywall screw into the fixture here. And I'm going to probably do the same thing on the forward fixture as well, where it intersects a rib. It's going to be a neat trick to do rib and into the fixture at the same time. That keeps me against the fixture. Probably overkill on all this, but because if you hear that, that's slapping. That's right against the surface. There's a little slap you hear. There's the contact. I got good contact. A little bit of slapping. Good contact. So maybe right in here when I put this drywall screw into that rib, I get really good contact. Check that all over the surfaces, and wherever you think you need a screw, drop in a screw. Do what it takes to do it. It's not a big deal. And you can easily fill all these things later. You notice I've got an extrusion on here large hole drilled in it to handle the diameter of the screwdriver. And I've picked up the positions down below. Now I know I've got a dead straight line here. Good contact. The trailing edges are making contact here. I'll probably use 2 more straight edges here to hold this in. I've opened these up. Now of course I've got to take this off, open them up all the way through the skin, but not into the rib, and I'll be ready with the winglet. The winglet's ready to go. Now I'm going to do that on a few strategic positions on ribs that I don't think I'm going to have a good opportunity to weight. I can obviously weight easily on top of this rib because I've got a support underneath it. I don't want to put a lot of weight here because I can flex the wing in this area. There's no fixture underneath this one, so I might put a drywall screw here and a drywall screw here to make sure I get good contact there. Maybe a couple. Not going to bother here. I'll do 2, maybe 3 here, and a couple here. I'll be very careful in this area because this is where my tank is. I probably won't put any screws in there, as a matter of fact. I'll weight that. The wing is thicker here, deeper here, it's less likely to flex here. So just screws in the aft section, and then we'll go inboard, and we'll do some screws in here where it's blind, where we don't want to put a lot of weight, and we'll give you an update as we go. If we haven't stressed it by now, I'll stress it right now. For you to go through any of these drilling processes and not have everything precisely in position, you are creating a very difficult situation. I'll drop in 1 screw here, 1 screw here. Then I know with the clecos in here and here that when I go to drill, and I'd click on the leading edge, when I go to drill this one up through here, it will be in the right place. Otherwise, all bets are off. Actually, even just 1 screw out here would do the job. So we'll be back in a moment. Okay, we've got the screw in here in this rib, and that's nice and firm. Now we're not going to do this one because it's over the fixture. We got 1 last one here. I misdrilled this one because I don't have a drill bit long enough. I haven't drilled this one yet, but I knew where it was, so I'm going to drill that one right now. I'm in the rib. Okay, I'm not even going to go all the way through. I know that one. The rest of them I'm going to do with weight. We are ready to do the bonding, and we'll switch tapes.